Jai Hind, my name is Vivek Agrawal. I'm the assistant professor in the Department of Computer Science and Engineering of AKGEC Ghaziabad. So today we are going to have a lecture on time series data analysis and forecasting. It is a very important topic and very interesting thing. If you see, if we are going to forecast something, forecast means when we are predicting something. One of the most common example could be the weather forecasting, could be the stock prediction, and could be the business predictions or business forecasting, and price forecasting, and demand forecasting. So in such kind of forecasting or the prediction problems, this time series data analysis helps us very much. See, if we need to forecast the weather, so how we can calculate or predict the weather, how we can forecast the weather, like what could be the temperature of tomorrow, or I must say when would be we can have the change of the weather, right? So how we can calculate or how we can predict this? Just think about it, right? So this is totally depend on the periodic data, the previous data, the time series data. Like you are having the previous data, previous experience, which is based on a fixed timeline. Means you are having a data which can be categorized or properly fitted within the timelines. This timeline could be of the days, could be of the weeks, could be of the months, could be of the years. So over a good amount of period. So if you are working in the weather, yes, this period could be of some 10 years, of 20 years, of 30 years, 50 years, 100 years, right? If we are talking about a particular segment of business, it could be a less amount of time. The period could be a less amount of time. So this period also will depend on the nature of the problem and the segment, the segment of the real-time problem. So but one thing is important, the data must be periodic and must be fitted in a proper timelines. These timelines could be in months, seconds, hours, days, weeks, years, right? So let's start with this time series. We will understand what are the time series, what is time series data, and how we can analyze that data, and on that basis how we can forecast the future predictions. So let's understand, time series analysis is the statistical method to examine and understand the sequences of data points collected at a constant interval over the time, identifying the patterns like trends and seasonality to forecast future values and make data driven decisions. So this paragraph is telling us a lot of things. The main point is statistical method. The first key point you must understand the statistical method, and second is examine and understand the sequence of data points. What data points? These are the periodic data points collected at constant interval over the time, periodic data. Identifying the patterns using some statistical methods, we need to analyze some patterns out of them. What kind of patterns? What is the trend? Like in weather, we are having a trend. In few months, we are having the summer. After that, we are having some comfortable days. Then we are having the winters. Then we are having some spring season. Then again, we are having the summers. So it is a fixed trend towards which we can predict. Or I must say, like if the wind is dry and the temperature is going down, we can say it is a trend towards the winters. When the temperature is going to reduce after the summer, whenever the temperature is reducing, means like if the 10 days before the temperature was 40 degree, then it is constantly reducing over a time. Day by day, it is reducing either 1 degree or 2 degrees. So it tells us a trend. Like the trend is toward the temperature downside, which can be substituted towards the winters. We are proceeding towards the winters, called as the seasonality, which shows us the seasonality. to forecast the future values. On this basis, after this analysis, we can predict or we can talk about the future values and make data driven decisions. Yes, on these predictions we can make some better decisions, right? This involves decomposing data into components. Again, important point, the periodic data we have with us, what we need to do is we need to decompose that data into what? Into several components. Components, what kind of components? Building models and applying techniques such as ARIMA or exponential smoothing to extract meaning from dynamic data for applications ranging from finance and sales forecasting to weather prediction and the health monitoring. So first, we need to decompose the data into some components. What are these components? In coming slide, we are going to have a look on these components. A few of them are already mentioned here, like we need to decompose them into some trends, seasonality, etc., etc. Then building the model on that. Once we extracted the components, then we need to build a model on these. I must say that these trends, seasonality or other component, we need to make a model. Model like it could be machine learning model, data analysis model, data analytics model. We need to make a model through which we can predict or we can analyze the futuristic values. So for creating the models, we have some techniques called ARIMA, exponential smoothing, and etc., etc. We are going to deep dive in future slides. Meaning, which are used to extract the meaning from dynamic data. The whole data we are having with us, the original periodic data, we are extracting the meanings, full data from these dynamic data for application ranging for my real life application or real life problems. And these problems could be of which segment? It could be of the finance, it could be of the sales, it could be of the weather prediction, it could be the health monitoring, could be the stock prediction, etc., etc. So where it can be applied? Wherever the real-time scenarios or real-life problems where we are having the periodic data or we can generate the periodic data, simply we can apply this time series analysis, right? Each data point represents observation or the measurement taken over a time, such as stock prices, right, temperature readings or the sales figure. Time series data is commonly represented graphically. When we do talk about the time series data, what picture should come in our mind? The picture should be something like this. This is your time. This is your time, and these are some values, and on this basis we are having some charts like this, right? So when we do talk about the time series data, what comes our mind? Represent graphically with time on the horizontal axis and the variable of interest on the vertical axis, allowing analysts to identify trends, patterns and changes over the time, which tells us how the data is changing over a time. A particular value of my interest is changing over a time. Towards which direction? To the up direction, to a lower direction, or a stagnant, etc., etc. Time series data is often represented graphically as a line plot. The most commonly used plot, visualization plot for time series data is line plot, with time depicted on the horizontal x-axis and the variables value displayed on the vertical y-axis. Already I told you. How it is seen? Like this. Already I told you. This is the time intervals. It could be in seconds, it could be in minutes, right? If we are working with the stocks, then it could be seconds. It could be minutes. It could be day. It could be weeks, it could be month, it could be years, it could be decade, it could be etc., etc. So this is your time components, or I must say the time scales, and these are my value. This is my value on which I am interested to find the changes or to find a pattern, how the values is changing over a period of time, right? So this is the most common, I must say, the chart which generally seen for analyzing any time series data. So time, what is the time series data? Sequence and dynamics. As I told you initially, what we are going to understand, what is time series data, what is time series data, and how we can analyze, and after the analysis, how we can forecast. So what is time series? Time collection data consists of observation made sequentially over the years, over the months, over the decade, over the days, over the months, over the minutes, right? Months, days, hour, minutes, and seconds. So this time could be, the time series could be on the basis of these factors. Frequently at normal intervals, including daily, month to month, or each 12 months for the yearly. These information factors could constitute diverse phenomena such as inventory expenses, temperature readings, earning figures, or even internet site visits. We are talking about, in this point we were talking about this scale, what it could be, and in this point we are talking about this scale, what it could be. It could be the inventory expenses, temperature readings, earning figures, or the internet site visit, etc., etc. Could be any value of my interest. The key feature of time series record is its chronological order, this chronology, which needs to be maintained at all through evaluation to keep the temporal relationships among observations. Like if this point, this interval is of 1 year, then another interval must also be a year. Again, interval must also be a year. Again, interval must also be a year, just to maintain this temporal relationship, right? Okay. What is the importance of time series analysis? So now we are having a good idea what is time series and what is time series data. Time series is when something is based on a fixed period of times. Time series data when the data is fitted or collected or arranged in a time series, right, over a period of time. And now we are talking about the importance of time series analysis. So we have a good idea now about the time series and time series data. Now the importance of analysis, then we are going how we can analyze that data. Predict future trends. Using such kind of analysis, we can have the idea, or we can predict the future trends. Like if we are having a data of temperature, weather temperature, right, the weather forecasting, in the case of weather forecasting, the reading of temperatures of a day temperature over a period of several years, suppose over the span of 25 years, if we have these readings, now we can find out a trend, we can find out a seasonality, we can find out the cycle of the temperature, how it is goes up, how it is goes down, how again it goes up, then down, up and down. So now we are having some patterns. Now we can make some relationship. We can, if we break the data into some months, we can have another relationship, like in which fixed month it goes to upside, in particular which duration it goes to downside. Again, we can analyze, we can predict, like to whole, out of the whole duration, to which amount of duration it is going to the downside, or it is having min and max between this boundary, and another this duration it is having this min and max boundary. So these kind of the analysis can be performed on that data. So on that basis, we can predict what could be the next outcome on the basis of the same cyclic event, or same kind of the pattern, or same kind of the seasonality. We can predict what could be the next season, what could be the next trend, or what could be the next phase of the cycle. Detect patterns and anomalies. Yes, using this we can find out, suppose if in a long term data, in last span of 30 years data, the maximum weather, generally the ideal maximum temperature of the weather is suppose 40 degree or 42 degree, but in any someday or in any duration, if it is spike for a once only, it is a spike towards the 50 degree, then that could be considered as an anomaly. So for finding the anomalies in the data, we can analyze this. we can find out or detect some patterns out of them. So by examining the sequential data points, time series analysis helps detect recurring patterns and the anomalies, providing insight into underlying behaviors and the potential outliers. Risk mitigation. Yes, analyzing the trends. Suppose if we talk about the rain prediction, if we have a prediction that it could be rain tomorrow, then we can minimizes the risk. Like if for any farmers or a land, for a country or for a village where the farmers are in a good amount and they are having their new crop which is underlying the sky, and just due to rain it can be harmed, it can be wasted. So if we have the right prediction on the right time, we can manage this risk. In the sales, we can manage the risk whenever a particular event is going to be executed. In the stocks, if we are having a good prediction over the stock market data, then we can mitigate the risk of my losses or our losses, right? On that prediction, we can either sell or buy the new stocks. So by spotting the potential risk, businesses can develop the strategies to mitigate them, enhancing overall risk management. Strategic planning can be done in the same way risk mitigation. The strategic planning can be done on the basis of some forecasting, like if over the period of time I just saw in the winters the sale of particular product, or I must say the woolen product is going to be rise, then I can make a proper strategies or proper planning just to fulfilling the requirements of these, I must say the hiked requirements or the additional requirement in increasing in the requirement while these days or while these seasons. So better planning or strategic planning can be done for such kind of scenarios. Competitive edge. If I am doing the right analysis over the period of data, then I can have an edge over my competition. How? Time series analysis enable businesses to optimize the resource allocation effectively, whether it is inventory, workforce, or financial assets. By staying ahead of the market trends, responding to the changes, and making data-driven decisions, businesses gain a competitive edge. So if we do talk about time series modeling, common applications, as I said earlier, wherever in any industry, any segment, any real-time problem where we can have a data which can be classified or which can be fitted into some periods of some time intervals, we can arrange that data into some fixed time intervals. Then we can apply time series data analytics on that. Out of them, these are some sectors which are most prominent for such kind of modeling or analysis. Finance, predicting like stock prices, market trends. It could be the business trends as well, like whether my business is in the growth trend or in a loss trend, etc., etc. Retail, in forecasting sales to optimize inventory and manage supply chains. Like in winters, we are having the spike rise in the demand of some kind of the products. In summer, we are having the spike of sales of some particular class of the product. So likewise, healthcare, monitoring heart rates, EKG, and the brain activity, EEG, to detect anomalies. Likewise, many other applications are also there of the healthcare as well, where we can apply this, like BP management, BP monitoring. It could be like your blood sugar monitoring, etc., etc. Environment, analyzing the weather patterns and the climate change, very important. Now if we do talk about the components of time series data, as earlier we were talking about the decomposition of data. So these are the 4 components in which that data can be decomposed. One is trend, another is seasonality, irregularity, and cyclicity. Trend, generally trends tells me my trend is towards the up direction or towards the lower direction or to somewhere another direction. Point is, the trend is all about direction. After analyzing the periodic charts or the time series data chart, we can have some prediction, or we can analyze, we can say this whole scenario is going towards this direction. This particular segment of data is showing this direction, is going to this direction. Somewhat in, I must say, in stock prediction, generally we say it, the market is towards the bullish, or market is bullish, or the market is bear. So this is the trend we are talking about. We are analyzing the data on the basis of that periodic data and telling the trend. The market trend is towards the bull or towards the bear. Seasonality tells us some fixed durational spikes in the whole data. Suppose on average we are having this kind of chart, but a particular moment it is spiking like this. So this is tell me the seasonality. This is the on season and this is these are the off seasons, right? So kind of the analysis or kind of the pattern identification tells us the seasonality. Like if we talk about the woolen clothes, it has the seasonality. Only in winters it has the spike in its sales. In rest of the months the sales are like this. So after analyzing the sales data of woolen clothes, we can identify the duration, the season. Like this is the 3 months of duration out of the whole year, which is spiking on every year. If we have the data of several years, so after a particular interval on a particular segment of time, we are having these spikes again and again. So this is called as the seasonality, right? Next we can come with the cyclicity. Cyclicity is something like this. If we analyze the data of suppose weather forecasting, so we are having the data of 30 years. If we see there is a cycle, if you say if we are having the weather data, weather forecasting data, or the weather data of India, then we are having a fixed cycle. Initially we start with, if say we start in the January, then we are having the winters, then post that we are having the springs, then we are having the summers, then we are having the rainy season, then again we are having the winters. So this is the fixed cycle which is repeating since last 30 years, 50 years, 100 years. So this kind of the trend analysis, or sorry, this kind of the analysis is called as the cyclicity. So when we are having my whole data, the periodic data, that is decomposed into trends, seasonality, cyclicity, and another main component could be the irregularities called as the anomalies. Already I had discussed. So these are the main components. These are the main components, not the only component, but the main component of any time series data. So already we had gone through the definition and examples. Trend is a lengthy term movement of the direction. As I told you, it is based something on the direction. It is based on some spikes and it is a fixed circle. So direction within the fact over the years, it represents the general tendency of the fact of growth, decrease, or life stable over the extended length. Example is ordinarily a word fashion in the annual revenue over the several years suggests constant industrial company growth. If we are having this kind of this pattern like this, if the sales data is like this, simply we can see it is showing me the growth over a period of time. The company revenue or the company business is towards the growth side. Seasonality refers to the periodic fluctuations, as I showed you, the spike or style that repeat at regular intervals. If in a periodic data, if it is repeating again and again every year, frequently pushed by means of the seasonal elements like weather, holidays, or the monetary cycles. As you see, generally on Sundays or holidays, there used to be a more rush in the malls, business malls, shopping malls, and the movies theaters, right? So all this is called as the seasonality. Cyclic, where we are having a fixed circle of the some phases or the some must say the some seasons, the fixed cycle of some phases. It could be some seasons, it could be some conditions, or it could be some scenarios which are being repeated again and again in a cyclic way. But yes, one major difference is the duration. In the case of seasonality, the duration is generally a fixed duration and generally of similar type of the duration. But in the case of cyclicity, the phase of the cycle could be vary on every cycle of every, I must say, the every cycle or every turn. In a one turn, this cycle could be of total cycle could be of 1 year, but maybe the another cycle could be of 5 years or 3 years or 2 years. So this is the major difference between the seasonality and the cycle. Noise, already I have discussed the outliers. So if we talk about the process, I must say the steps for analysis or analyzing the time series data. Already we have a rough view, but now we are having a final view or a furnished view. First, we will have to collect the data. How to collect the data? Gather data points at the consistent interval over the time, which is simply called as the time series or time series data. Then we need to make some data pre-processing. We need to clean the data. There used to be various, I must say, the irregularities, various issues with my collected data. So I need to furnish that data for making the right prediction. If my data is having some noise which is not properly pre-processed, then there could be variation or maybe some misinterpretations, or I must say the misrelationship could be built there, and on that basis we can have a wrong forecasting or wrong prediction. So data pre-processing is a very important phase in this whole process. Clean the data, handle missing values, and prepare it for the analysis. If it is not prepared well, if it is not a proper format, then we need to format the data in a particular format as we can make some analysis on that data. Then visualization, plot the data over time to visualize, to visually identify trends, seasonality, and other patterns. Yes, your machine, your computer is going to do all this pattern analysis, your trend analysis, seasonality analysis, cyclic analysis mathematically on the data. But if you want to visualize, if you are going to visualize this data, you would be able to find it with your bare eyes as well. Just to have a better look on it or better understanding of the data, you must visualize using some plots. Line plot is one of the major type of the visualization technique can be used. Then further decomposition, break this data into multiple components. Main 4 components. First is your trends, seasonality, and then your cyclicity, and fourth is your noise or abnormalities. Break down time series data into component, trend, cyclic, and the residual. Then final modeling. For the modeling, we are having various techniques. Through applying these techniques, we can make a model on which we can perform some future forecasting or future predictions. Then finally forecasting on that, and last one is the model evaluation. How efficiently this model is predicting, this model is working, this model is performing, how efficiently, how correctly. So we can assess the accuracy and effectiveness of my forecast. So these are the steps for making analysis. Different time series visualization, line plot commonly used and mainly used for visualizing the or having a good analysis over the time series data. Others are the seasonal plots, histogram and density plots, autocorrelation and partial correlation plots. Spectral analysis we can do using such as periodograms and spectrograms. Visualize frequency components within the time series data, useful for identifying periodicity and the cyclic pattern. Just to identify these two kind of the components, we can have some spectral analysis. And the decomposition plots. Decomposition plots breaks down a time series data into its trend, seasonality and residual components, aiding it in understanding the underlying patterns. So these are the plots, and these are some techniques. Which techniques? Modeling techniques. Out of them, naive methods, the basic methods for making the models of a time series data. Naive methods, these are the simple estimation techniques, such as the predicted values is given the value equal to the mean of the preceding value, the time dependent variable, or the previous actual values. These are used for the comparison with sophisticated modeling techniques. As I told you, the function of these models or this model is very simple, very basic, and based on simple mathematical calculation of using the mean values of the whole data. Another technique is auto-regression. Predicts the values of future time prediction as a function of values at the previous time periods. Prediction of auto-regression may fit the data better than that of the naive methods, but it may not be able to account for seasonality. Every technique is having its some advantages and some limitations. So we can choose the technique for my modeling depending on the problem, depending on my data, right? So these are the two main factors in every data analytics and the machine learning: which type of the problem you are working on and what kind of the data you are having with you. So these are the two main factors of your choices among the available methods. ARIMA and its variants. Some variants are seasonal ARIMA, fractional ARIMA, and VARIMA, right? Yes, so these are the very commonly used modeling techniques for the time series data analysis. How it works: an auto-regressive integrated moving average, as I show you in previous one of chart, like this. This green dots are the moving average of all the data, right? So this works on this moving average. Moving average models the value of the variable as a linear function of the previous value and residual errors at previous time steps of a stationary time series. However, the real world data may be non-stationary and have seasonality. Thus, the special case of this seasonal ARIMA and the fractional ARIMA were developed. ARIMA works on univariate time series, but to handle multiple variables, we are having the VARIMA was introduced. So this is all about the VARIMA model. Likewise, some exponentially smoothing model is there, and LSTM. Again, LSTM is also very popular technique and used widely. Long short-term memory models. LSTM is a recurrent neural network which is used for the time series to account for long-term dependencies. It can be trained with large amount of data to capture the trends in multivariate time series. So this is all about the time series analysis. Thank you.